Have you ever wondered, how do we know for sure that something like a jet engine turbine or a life-saving surgical implant is absolutely 100% perfect? Well, today, we're going to pull back the curtain on the hidden science that makes all of modern manufacturing even possible.
Okay, so take a look at this. It's a really complex part, right? Probably 3D printed for something super critical, like in aerospace or medicine, and, it looks flawless. But here's the thing. In the world of high-tech manufacturing, what you see, that's only half the story. The real question, the one that keeps engineers up at night, is what can't you see?
And that's the heart of the problem, isn't it? A tiny microscopic flaw, something you'd never spot with your own eyes, like a little crack or a bubble trapped inside. Well, that could lead to a catastrophic failure. So how on earth do you find these hidden dangers and, guarantee perfection?
Well, the answer has a name. It's called metrology. And no, that's not the weather forecast, that's meteorology. This is the science of measurements. And honestly, it's the absolute bedrock of modern engineering and quality control.
So what does that actually mean in practice? It really boils down to two key things. First, you've got dimensional accuracy. Simple enough, is the part the exact size and shape it's designed to be? And second, something called quantifying uncertainty. Now that sounds complicated, but it's just a fancy way of saying we know exactly how small our margin of error is. It's the difference between saying, yeah, I think this is right, versus I know this is right, down to a single micrometer.
And to really get this, we've got to talk about two words that people often mix up: accuracy and precision. Think about throwing darts. Accuracy, that's hitting the bullseye. You hit your target. Precision, that's hitting the exact same spot over and over again, even if that spot isn't the bullseye. In manufacturing, you need both. You have to make the right part, and you have to make it right every single time.
Okay, so how do they actually do this? How do engineers and technicians see the invisible? Well, they've got this incredible toolkit of high-tech gear. Let's peek inside and check out the three main methods they use.
All right, first up, we have the absolute workhorse of the metrology world. It's called a coordinate measuring machine, or a CMM for short. The easiest way to think about it, it's like a hypersensitive, super precise robotic finger.
The way it works is actually pretty straightforward. This little probe physically goes and touches the part's surface, here, here, and here, taking thousands of individual measurements, your classic X, Y, and Z coordinates. Then, the software connects all those dots, basically building a perfect digital map. And the final step? It compares that map to the original design file to see if it's off by even the tiniest fraction.
Okay, but what if the part is insanely complex with all these weird shapes? Or what if it's too delicate to even touch? Well, for that, you can't use a physical probe, so we turn to light. And this is where optical and laser scanners come into play, because they can measure things without ever physically touching them.
Honestly, the process feels a little bit like magic. The scanner shoots this pattern of light onto the object, and as that light drapes over all the curves and angles, the pattern gets warped and distorted. A super high-speed camera is watching all of this, capturing how the pattern bends. Then, really powerful software translates those distortions into millions, literally millions of data points, creating what they call a point cloud. It's this incredibly dense digital clone of the part's surface.
But hold on, both the CMM and the optical scanner have a limitation. They can only see the outside of a part. So what if the most dangerous flaw, the one that could cause everything to fail, is hidden deep inside? For that, you need something else entirely. You need a kind of industrial X-ray vision. And that's where computed tomography, or XCT, comes in.
If you've ever seen a medical CT scan, you already get the basic idea. The part is scanned with X-rays from every possible angle, 360 degrees. The machine takes thousands of 2D X-ray slices and then digitally stitches them all back together to build a complete 3D model, showing you everything, inside and out. This is a total game changer because you can find hidden cracks or bubbles without ever having to destroy the part by cutting it open.
So, let's do a quick recap. If you need the absolute best, most precise surface measurement, you go with the CMM's tactile touch. If you need speed and you're dealing with really complex shapes, the optical scanner's light is your best bet. And if you have to find flaws hidden deep inside, you need the XCT's X-ray vision. Each tool has its job, and they all work together to ensure quality.
Now, all of these technologies are becoming more important than ever before, and it's because of the explosion in additive manufacturing, what most of us just call 3D printing.
See, building parts one tiny layer at a time lets you create these incredible, impossible designs. But it also opens up a whole new universe of potential errors that are just ridiculously hard to control. This quote here really nails the central challenge. With 3D printing, it's not enough to just check the part at the very end. The real holy grail is to monitor the entire process while it's happening, to be able to spot tiny errors in real time and fix them on the fly before they turn into a major flaw.
And the challenges here are just huge. We're talking about things like detecting if the laser path in a metal printer shifts by just a few microns, or making sure that the metal powder is melting and fusing together perfectly on every single layer, or verifying that these super complex, hidden internal cooling channels are actually clear and not blocked. Metrology is the only way we can possibly meet these insane new demands for perfection.
But this isn't just a story about factories and 3D printers. The real impact of metrology, this science of knowing for sure, it actually affects all of us in some of the most critical parts of our everyday lives.
I mean, think about it. It's what ensures every single component on an airplane is perfect. It's what makes sure that radiation therapy for cancer patients delivers the exact right dose, no more, no less. It's absolutely essential for nuclear safety, for the car you drive. Basically, it's crucial in any field where failure is just not an option.
So when you boil it all down, metrology isn't just some obscure process for engineers. It's the hidden science that builds trust. It's the reason you and I can step onto a plane or trust a medical procedure or get behind the wheel of a car with confidence. It's because we know, deep down, that every single one of those critical parts has been measured, verified, and proven to be safe.
And all this leaves us with a really fascinating question for the future, doesn't it? As we start designing parts that are so complex that a human couldn't even assemble them, let alone inspect them, how will we continue to guarantee their perfection? The answer is these tools, this science of certainty, they're going to be the only thing that allows us to keep building a safer and even more incredible world.